Hello friends, now we are going to teach you Hooke's law. Hooke's law. What is Hooke's law? Hooke's law, also referred as the law of elasticity, was discovered by an English scientist named Robert Hooke in the year 1660. Hooke's law basically states that when an object has a relatively small deformation, the size of the deformation is directly proportional to the deforming load or force. Besides, Hooke's law is a great example to describe the property of elasticity, which is a tendency of an object or material to be restored to its original shape, offer some form of distortion. The ability to return to a normal or original shape can be described as a restoring force explained more clearly by Hooke's law. This restoring force is said to be proportional to the stretch that is experienced. Hooke's law can be usually taken as a first order linear approximation only to the response that spring and other elastic bodies offered when force is applied. The law will eventually fail after certain conditions. It fails usually when the forces exceeds some limits and the material reaches its minimum compressibility size or its maximum stretching size. Alternatively, there will also be some permanent deformation or change of state once the thresholds are crossed. In fact, some material will mostly start deviating from Hooke's law much before these limits are met. On the other hand, we can also say that Hooke's law is an accurate approximation for most solid bodies. However, this will mainly depend on the forces and deformation, whereas they should be very small. As a result, Hooke's law is extensively used in different branches of science and engineering. It is also the foundation of many disciplines such as molecular mechanics, seismology, and acoustics. Further, this law is the most fundamental principle behind the galvanometer, spring scale, manometer, and balance wheel of a mechanical clock. Now, Hooke's law statement: when a material behaves elastically and exhibits a linear relationship between stress and strain, it is called linearly elastic material. In this case, stress is directly proportional to strain, or we can say that for small deformation, stress is directly proportional to strain. Therefore, in simple terms, Hooke's law states that the strain in a solid is proportional to the applied stress within the elastic limit of that solid. Hooke's law equation. The Hooke's equation holds in many situations where an elastic body is deformed. The instances may include the wind blowing on a tall building or a musician playing the guitar. The equation is said to be linear, elastic, or Hookean, usually for an elastic body or material. Now, Hooke's law equation in terms of stress and strain. According to this law, within the elastic limit, stress is proportional to strain. Thus, Hooke's law equation can be expressed in terms of stress and strain. Stress summation strain or stress by strain equal to constant or E. Stress equal to Young modulus of elasticity into strain. Delta equal to E into E, where delta equal to stress, capital E equal to modulus of elasticity, also known as Young modulus of elasticity, and E equal to strain. In SI units, the spring constant K and each element of the tension K is measured using units such as Newton per meter or kilogram per second square. For continuous media, each element is therefore measured in units of pressure, namely Pascal, PA, or Newton per meter square, or kg per Newton meter second square. The elements of the strain tensor E are also expressed in units of pressure. For linear springs, mathematically Hooke's law states that the applied force F equation is constant K into the displacement or change in length x, or F equal to K into x. The value of K depends not only on the kinds of elastic material under consideration but also on its dimension and shape. All material exhibits some degree of elasticity. Due to this elastic property, an excellent concept of restoring forces comes into the picture. We can measure this elasticity property in the form of a restoring force. This restoring force opposes the deformation force and tries to maintain the original dimension of the material. Now consider the elasticity in only one dimension to variety Hooke's law on the spring mass system. We need to find the relation between the restoring force and stretch or elongation for a spring. As we know, the restoring force is proportional to the magnitude of the deformation. This restoring force can be written mathematically as F equal to minus K into X. This expression of the Hooke's law is also known as the spring constant formula. Here F is equal to restoring force, X is equal to represent the magnitude of the distortion or displacement from equilibrium as exhibited in the stretching of a spring or rubber band. K is the proportionality constant, also known as the spring constant. Note, here the direction of the force is in the direction opposite that of the displacement, so consider minus sign.